Hey, welcome to Unit 5, Section 5, Conditions for Rhombuses, Rectangles, and Squares. Let's check out a video to start from Sully's and Brust's Past Christmas.
Now, where are the twins?
Oh, they're still upstairs. They're super excited.
Those two will not stop talking about what they want for Christmas.
Tell me about it.
Merry Christmas, boys.
Ma, did you get us a calculator?
Are we getting a calculator?
I'm not telling you. You have to wait.
Glenn, guess what we're getting for Christmas?
Yeah, a calculator.
We're getting a calculator.
Yeah, that's great.
Do you have any idea how fast we're going to do math problems?
Square roots?
Lightning speed.
We are getting a state-of-the-art calculator by Texas Instruments.
Guys, we don't know.
Hey, how about that Christmas special with Sully and Brust? We're going to get more of that later. What we're going to learn about today is determining when a parallelogram is a rhombus or a rectangle. In the last lesson, we basically said, here's a rhombus, here are all the great things about it. But in this lesson, we're going to figure out how we know that the parallelogram is a rhombus or a rectangle. So we're going to have to write some theorems down. Pause the video if you need to. I know this is blank on your packet. First theorem, if the diagonals are perpendicular, then the parallelogram is a rhombus. So what does that mean? I'm going to try to draw the diagonals in fairly well. Let's see how Mr. Kelly can do. There's the diagonals. And they should appear to be perpendicular. It looks actually pretty good. We have to label the vertices of the parallelogram. So you can start anywhere, but I'm going to start up here. But remember, you got to go around in a circle. A, B, C, D. Okay, and this theorem says if ABCD is a parallelogram, so that's given, so you know the opposite sides are congruent. You know that they're parallel from each other. And AC is perpendicular to BD. So let's put a little right angle mark in here. Ta-da! If these diagonals are perpendicular, then this is a rhombus. That means that you can mark all the sides congruent. It's basically our conclusion there. That's really useful because, as you can see, we're going to get some proofs. And you have right angles here. We might have to use some hypotenuse leg. You can kind of see where we're going with that. So that's our first theorem. Next theorem, what else happens? How else can we prove a rhombus? A parallelogram is a rhombus. If one diagonal bisects a pair of opposite angles. Ooh, what does that mean? So here's a diagonal. Ta-da! Here's a diagonal. Well, let's just leave it at one. Let me go around and label the different sides again. So we have parallelogram A, B, C, D. All right, so what this says, if angle 1 is congruent to angle 2, so it has to bisect a pair of opposite angles. So I'm going to put it like, here's angle 1, and here's angle 2, and then maybe we can put 3 down here, and then 4 here. So if the diagonal bisects, so if 1 is congruent to 2, and 3 is congruent to 4, then you know it is a rhombus. That's our second theorem. That's our second theorem coming at you. And we don't want to leave out a rectangle. All right, so if the diagonals of a parallelogram are congruent, so we need to draw a rectangle. Here we go. Ta-da! Ooh, that looks kind of squarish. I don't like that. Let's get rid of the square. Let's add rectangle. Ta-da! All right, so if okay, the rectangle theorem. We only have one here. If the diagonals of a parallelogram are congruent, then it's going to be a rectangle. So let's see what that looks like. Let's label our parallelogram. This one does look like a rectangle here. And we'll put some diagonals in there. So AC is going to be congruent to DB. So I'm drawing those in. Pause the video and write this down if you need to write it down, and then you can listen. All right, so if the diagonals are congruent, all right, conceptualize this. If this rectangle here leans one way or the other, okay, think about this leaning like a box that's kind of weak or a table with wobbly legs. If it leans one way or the other, these diagonals are either going to get longer or shorter. Okay, the only way this can be a perfect rectangle with perfect right angles is if these diagonals are congruent. All right, so that's what the theorem says. If ABCD is a parallelogram and AC, which is from here to here, is congruent to DB. All right, if they're the same as each other, then it'll be a rectangle. Let's get some more of that Christmas clip. All right, time for some examples. Can you conclude that a parallelogram is a rhombus, rectangle, or a square? So basically, look at the picture and let's figure out what it is. All right, so the first example, 1A here. What do we have? A nice little parallelogram. We already know that these are parallelograms, so the opposite sides are congruent and the opposite sides are parallel. Is it a rhombus or rectangle? All right, what do we have here? We have a pair of opposite angles congruent. Okay, they're congruent to each other. Which one does that go with? The rhombus. Okay, how about the next one? We have diagonals perpendicular, so that means it's a rhombus. All right, rhombus. But we're not done yet. If all four of these are congruent, that means that this diagonal plus that diagonal is the same as this diagonal plus that diagonal. Basically, you have x plus x. 2x is equal to 2x. We don't know what the value is, but we also know this is a rectangle. So this brings up an important point that we talked about before. If it's a rhombus and a rectangle, then it's a square. So this is a square. That is the most precise name that we can come up with for part B. How about number 2? A parallelogram has angle measures of... All right, so let's draw that the best we can. Mr. Kelly's not the best at drawing these things. Parallelogram, 20, 160, 20, and 160. All right, can you conclude it's a rhombus, a rectangle, or a square? Well, it's definitely, let's see. I can't really conclude it's a rhombus because it doesn't say anything about the diagonals. So we don't know it's a rhombus. It also, we don't know that these are being bisected. Those are the two ways you can figure out it's a rhombus. A rectangle, it's definitely not a rectangle because there's no 90-degree angles. And if it's not a rhombus or a rectangle, it can't be a square. So, no, we cannot. No, can't conclude. It might be a rhombus, but we don't know. Okay, could also be just a regular parallelogram. 3, suppose the diagonals of a quadrilateral bisect each other. Okay, diagonals of a quadrilateral bisect each other. Can you conclude it is a rhombus, a rectangle, or a square? What do you think about that one? All right, so what do we know if the diagonals bisect each other? If they bisect each other, we know from previous lessons that means it's a parallelogram. Okay, can you conclude it's a rhombus, rectangle, or a square? Just if the diagonals bisect each other. Let's take a look here. It's always, you should always draw the picture, especially in geometry. So here is, I'm going to draw this looking thing here. What is that? How close am I going to be? That's actually not too bad. All right, so there's our parallelogram. If the diagonals bisect each other, we need to get some diagonals in here. So here's one. Here's one. Okay, if they are bisecting each other, not necessarily a right angle though. That actually looks like it's a little obtuse. So I can't really say it's a rhombus. They don't bisect the opposite angles. That's basically why they gave you this question, because the theorem is they have to bisect the one pair of opposite angles, like these or like these. Okay, if they're bisected, then it'll be a rhombus. But here they're talking about the diagonals bisecting each other. They're cutting each other in half. So I can't really say it's a rhombus. Can't really say it's a rectangle. And if it's neither of those, it can't be a square. So no, we can't. Okay, I kind of talked through that one. For what value of x is parallelogram a rhombus? Okay, so these have to be congruent with each other, right? The diagonal has to bisect those angles. So if they're congruent, if this is an angle bisector, that means these two angles are congruent and we can set them equal to each other. They should have the same measure. All right, so we just need to do a little algebra here. So we subtract 4x from each side. Algebra is easy, especially for you flip people. We know algebra is easy. You get 2x equals 10 and then x will equal 5. All right. And if you plug in x to each one of the angles, you get 28 and 28. That means that it's possible. Yeah, that works. You get x equals 5. They're both 28s bisected. Voila. Next one, a rectangle. Oh my goodness. For what value of n is parallelogram brus a rectangle? Okay, so if we look at what they give us ut, which is this half diagonal, and st, which is another half diagonal. Okay. The diagonals of a rectangle are congruent. So half of a diagonal is congruent to the other half of the diagonal. If the entire diagonal is congruent, if both of them are congruent, if B to U is congruent to S to R, which is what a rectangle, that's our theorem, that means that they bisect each other because it's parallelogram, so that their halves would be equal to each other. So how would we set up an equation? Well, if they're equal to each other, then n squared is going to have to equal negative 3 plus 4n. UT is going to have to equal ST, which means that n squared equals negative 3 plus 4n. Bells should be going off. This, ta-da, is a quadratic equation. If you move everything to one side, n squared minus 4n plus 3 equals 0, then you do the magic x. Remember, you got 3 times 1 goes in the bottom, negative 4 in the top. What two numbers multiply to this number, but they have to add to that number, negative 3, negative 1. Tell you what, let's go back and watch Sully do this exact problem.
Solve, so we have to get this equal to 0. So I have to move both of these things to the other side. So I'm going to add 3. So n squared plus 3 equals 4n. Got to get this to the other side, subtract 4n. Now remember, we need this in standard form, so n squared minus 4n plus 3 equals 0. If you don't have it in standard form, it's going to mess up your thing over here, your magic x. So the last number goes in the bottom, the middle number goes in the top. Two numbers that multiply to 3, 1 and 3. 1 plus 3 is 4, so these need to be negative. So now I have n minus 1 times n minus 3 equals 0. Booyah! Zero product property says the factors, if two factors equal 0, I can set each of them equal to 0. First factor equal to 0. Second factor equal to 0. Add 3 over here. So n could equal 3. Or add 1. N could equal 1. Boom.
All right, we're back. So that was lesson 10.4. Some of you have forgotten how to factor. I do not even have to ask you because I know you have. It's been a very long time. So you need to go back to the algebra lesson 10.4. If you forgot, the video's already there. Just go watch it again. You have to set them equal, move them over. Voila, Sully went through the whole steps right there. But you have to solve it. You get 1 or 3. I'm going to plug it in to see what is possible for these half diagonal lengths. All right, so if you get an answer of 1, you get 1 squared, which is 1. Okay, and negative 3 plus 4, that'll give you a 1. What if we plug the 3 in? 3 squared is 9. And what do we get? Plug a 3 in, you get 12 plus negative 3. It's also a 9. So it works. Okay, so you have to check both of those. By the way, you should always plug in your answers to both of the, in this case, the line segments, the half diagonals, because if your answer comes out negative, we get to throw that answer out because you can't have a negative distance. Okay, but you have to try both. All right, next question. You try to, I put a factoring one on there. Try it. We'll see how you do.
Guys, we don't know what you're getting. Nobody promised you anything, okay?
But Dad, come on, who are you kidding? We didn't even ask for anything else.
When we went to Macy's, I saw you ask the guy at the counter if they sold calculators.
Okay, so I went through the hard part and set it all up here. Got the quadratic equation, moved everything over, and we have a magic x problem here with negative 48 in the bottom, 8 in the top, and you get 12 and negative 4. So, were you able to do that? I hope so. You get z plus 12 and then z minus 4, all right, equals 0. What two numbers multiply to negative 48? Okay, 12 and 4, they have to add to 8. Okay, so as we solve this, remember the zero product property. Z plus 12 can equal 0, or z minus 4 can equal 0. So you get z equal to negative 12 and z equal to 4. So in the last problem I said, hey, watch out if you get a negative, you got to plug it in and check it. And if that answer is negative, it's not possible because this is a rectangle. You can't have negative lengths on a rectangle. So let's plug in these values and see what we get. I got a negative 12 and a positive 4. So first we'll plug in the negative 12. Negative 12 squared. All right, so z squared. So if I get negative 12 squared, that's 144 positive. All right, and negative 12 into this equation here, so we get 48 plus negative, what do we need, 12 times? All right, 12 times 8, what do we get there, 96. So it's 96 plus 48, which is 144. All right, so that answer checks out. It's good. The z is negative, but when I plug it in, it ends up being positive, so that one's okay. Let's plug in a 4 and see what happens. If we plug in 4, you get 4 squared, and 4 squared is 16. All right, and over here on the right, we plug a 4 in, we get negative 32 plus 48, which is also 16. So we're good. So both of these answers here are sufficient. You can get z equals, you got to put them both, negative 12 and z equals 4. They both work out. Okay, the next problem deals with a rhombus, and for what value of x is the following a rhombus? Well, it's a rhombus if the diagonals are perpendicular to each other, so we know that this angle here is 90 degrees. Okay, sometimes they'll give you both angles in one of the vertices here, one of these angles, because they bisect each other, but that's not what this one's going for. This problem's going for, you got a right triangle now. Look, 1, 2, 3, and you have a right angle in it, so all 3 of these angles added together, they give you that one, and they give you the other 2. All right, let's do that. 90 plus 3x plus 6 plus 8x plus 7. All of those angles, the sum of those should be 180 degrees. So now it's just combining like terms. We're going to get 11x. What do we get? 103 equals 180. If we subtract 103 from each side, what do we get? 77. X will equal 7 here. Find the value of x. I'm double checking, make sure I don't have to find one of the angles. Let's plug it in though just to see if we get it. What do you got? 7 times 3 is 21. That means you add 6 and you get 27 degrees for that angle. This angle down here, we get 8 times 7, which is 56, plus 6, you get 63. Is that a possible combination? 90, 27, 63, all that up to 180. Hey, so we're done with that one. So the things you need to remember about this section. Rhombus, the diagonals are perpendicular to each other, which means you have a 90-degree angle there. Also, they bisect. Okay, these angles are going to be bisected, these angles are going to be bisected, that forms congruent angles there. For a rectangle, the diagonals are congruent to each other, so you can always set them equal. That's how you do it. We'll see you in the next section. We have one more section. This is Mr. Kelly Baumholder. Remember, it's nice to be important. It's more important to be nice.
Ma, we're gonna get a calculator.
That's all we want, Ma.
I'm gonna add so many numbers together.
I'm gonna keep dividing numbers until there's like 50 numbers after the decimal.
Why don't you just use the calculator on your computer?
Shut up, Glenn.
Nobody cares what you think.